config maps and secrets allow you to have one code base and several deployments by providing you with an API to store configuration values and sensitive information in Kubernetes and retrieve the information in various flexible ways. All right. So the concept of config map and secrets is very simple. There are sets of key value pairs, which means that a config map entry is a set of key value pairs. So it's not a single key and a single value, but it could be several keys mapping to a particular corresponding values. And this set of key value pairs is one config map. The way config maps can be used is rather flexible. We'll see that you can use a config map to store a configuration file within Kubernetes, as long as the configuration file is smaller than 1 megabyte. It will do the trick for even most configuration files of applications. For example, when we in the later sections we look at stateful sets, we will use configuration files to configure a particular data service, and these files can be stored as config maps. We'll create user credentials that will be stored as secrets. So key values, and sets of key values. The difference between config maps and secrets is it's rather subtle. It's basically the same concept. There are certain types of secrets, as we will learn. For example, one type we've already encountered, which was the TLS secret, where there's a defined key, two defined keys, one for the certificate and the other for the key, so that the ingress can read the certificate to terminate an SSL certificate for HTTPS connections. So in this case, the type secret for TLS is advantage because the structure has been defined, and therefore all ingresses will use that particular type and will reduce the heterogeneity of configuring SSL certificates for different ingress implementations. There are also generic secrets, and we'll just have a look at them throughout the following lesson. So keep in mind that config maps and secrets are the basic concept is each entry, each config map entry, for example, is a set of key value pairs. All right, so let's see what this means in practice. Creating a config map from a configuration file is one of the tasks, so that may occur frequently. Let me remove this. So let's create a config file. Well, this one is surely smaller than 1 megabyte. Could be much longer. A megabyte is actually a lot of text if you really use it to the full extent. So in this case, we don't have any particular assumption. We are not making any particular assumption about the structure of this config file. It is just a text file. All right, so no magic happened here. We created the text file. Here it is. So the next step is to create the config map. So again, we have kubectl, create the kind of object we want to create. In this case, it's a config map. It's a Kubernetes native resource. It's present in every Kubernetes. We call it the object we create. We call it config example1, and we tell him to create it from a file, and we provide them with a file name. So here we got the config map created, kubectl get config maps. Here's our config map, kubectl. You can either get the config map, kubectl get config example 1. Yes, config map. So that doesn't tell us much. We can output it as JSON. That gives us a little bit more information than the ordinary output. And this one is interesting because it also gives us some information about the structure of the key value pairs we've created. So data is always where the data of the config map is stored, and you can see that we have created a key that is called what our file name was. So it's 20 minus config minus file.conf, and the content is basically the entire content of the file. So it slurped the file, it read the file, and stored it as a key, as a value corresponding to the key, and the key is the file name. So this way you can just, use the config map as if it was a file, and we will later see how this will work out. So okay, kubectl describe config map. We'll use the same name. Oh, not this one. Example config example 1, and you can see that this will give us a different perspective on it. You can see here's your data section, there's your key, and here is the value of the file. So if you compare that with the JSON output, I personally think that as a programmer, in this particular case, I like the JSON output a little bit more because it provides me a clearer understanding on how the config map looks internally. So you can see that this is our hash, which is basically a set of key value pairs. Most of the time, hashes are not sorted, so there are ordered hashes too. But so let's say this is our key and this is our value. So the structure of the data in the config map is pretty clear when using the output format JSON. We can also use the output format YAML. And as you can see, it uses white spaces and YAML format. If you're familiar with YAML, that will do the same trick and serve the same purpose. But I think, personally, I like the JSON output because it's very explicit. All right, that's not the only way we can create config maps, though, because not always we do have application configuration files, and without having a configuration file, there shouldn't be a need to create one just for storing simple values, especially if the configuration values we want should be accessible, more fine-grained. So the problem with this config map we've created earlier is that the content actually suggests, like here, that there are key value pairs in the configuration file. But to Kubernetes, this is just a string. As you can see, it's a string. It doesn't know about the structure of the configuration file. And this is fine if you don't want to read these individual parameters to be used somewhere in a Kubernetes pod, because most likely you will feed this entire configuration file into a program that also knows how to parse and interpret this configuration file. So if that's what you want to do, like reading and storing the entire file as a string is fine, because feeding the string into the program will be enough. If, in contrast, you want to feed a list of key value pairs into your application, you may want to store individual key value pairs as a collection, and not only reading an entire file and then leave it to your application to read it. And this can be done too. So in this example, we are creating the config map from a so-called literal. So you may be familiar with literals from programming languages, where you can initialize a variable by providing a value that will automatically determine its data type, or at least, you know, assign the value to the variable. So you don't have to declare the variable in one statement and add the value or assign the value in another statement. You can often have both in the same line. So in this case, you can create the config map and at the same time assign values to. And by indicating from literal, you will be able to provide a list of keys in the following form. So this is the command line option. So you basically tell, I want to create a key value pair from literal, and then you have another key value pair as an argument. So this first equal sign basically separates the command line option from the argument, from the value of the option. And in Kubernetes, then the second equal sign, the second equal sign will be used to separate the key and the value pair. So in this case, a very important switch is set to true. So let's just create a config map, and again, and here you can see the difference. So let's compare them side by side. And you can see here you get one key and all the content. And here you get two keys and individual values. So obviously this is more fine-grained, and we can see how these two config maps can be used in pods. So deleting config maps are also straightforward. We don't have to go into that. I think you have up to this point deleted many Kubernetes objects, so that's a no-brainer.